Good morning or good afternoon. Today we begin a new module, Module 6, which is just an extension of Module 5 on functions. Our standard today is 8F4. We're going to be able to construct a function model for a linear relationship, find the rate of change, and then graph this as well. So by the end of the lesson, you'll be able to determine a linear function given a verbal description between two quantities, and you'll know you're successful when you can interpret that function based on the context of the problem and graph it by making a table of values, plotting points, and drawing a line. Let's go ahead and get started. All right, beginning with example number 1, it says logging on. Lenore has just purchased a tablet computer, and she's considering purchasing an internet access plan so that she can connect to the internet wirelessly from virtually anywhere in the world. One company offers an internet access plan so that when a person connects to the company's wireless network, the person is charged a fixed access fee for connecting, so they get charged just to connect, plus an amount for the number of minutes connected based upon a constant usage rate in dollars per minute. Lenore is considering this company's plan, but the company's advertisement does not state how much the fixed access fee for connecting is, nor does it state the usage rate. However, the company's website says that a 10-minute session costs 40 cents, a 20-minute session costs 70 cents, and a 30-minute session costs $1. Lenore decides to use these pieces of information to determine both the fixed access fee for connecting and the usage rate. Super long problem, but we're going to break it down. So we're going to do our close reading. We just read for the big idea. This time I'm only going to underline the important information or highlight the important information that's in here when I read it, okay? So she's purchased a tablet computer, she's considering purchasing an internet access plan, blah, blah, blah. One company offers an access plan so that when someone connects to the access network, they're charged a fixed access fee for connecting plus an amount for the number of minutes they've been connected based on a constant usage rate in dollars per minute. So they're going to get charged to basically connect, and then they get charged for each minute that they're connected, okay? The company does not state how much the fixed access fee is, nor does it state that rate. So it doesn't tell you how much it charges to connect, and it does not tell you how much it charges each minute. But they say that a 10-minute session is 40 cents, 20-minute session is 70 cents, and a 30-minute session is $1. She decides to use these pieces of information to determine both the fixed access fee and the usage rate. Okay? We've underlined the important information. We'll mark our second box. This third time, maybe we're going to pull out some information from what we have highlighted. Okay? So I'm just going to read the parts that I've highlighted. It says, charge a fixed access fee plus an amount for the number of minutes connected. So she's charged this plus the amount for the number of minutes. So access fee plus the number of minutes. Okay, so she gets a fee for every minute that she's on this plan, this wireless network. So the cost equals the access fee plus the number of minutes fee. Okay. The other information it gives me is that 10-minute session is 40 cents. So this is 40 cents equals the access fee plus 10 minutes times this fee, the connection fee. The 20-minute session is 70 cents. So we have the access fee, and this one is 20 minutes times this other fee of being connected per minute. And then the last one here is 30-minute session. It's going to cost $1. So the total cost is $1. And this is the access fee plus 30 minutes of this other fee being connected. So I've just read for my third time. I've pulled out really relevant information that's going to help me as we continue with this, okay? And we're actually going to continue with this on the next slide. So basically we're going to take this information and they've put this into a table for us, okay? So let's go ahead and click to the next slide now that we're done with our close reading for example 1 and start to actually figure this thing out and solve it. All right, moving to exercise 1 from that example. It says she makes a table of that information from that last slide and a graph where the number of minutes is represented by the horizontal axis, you'll see down here, and the cost is represented by the vertical axis, you'll see it up here. It says plot the 3 given points, and they're going to appear to make a line, and what information could suggest that this is a linear relationship, okay? So we have 3 rows in this table that we can plot. We know that in 10 minutes, she's charged 40 cents, 20 minutes, 70 cents, and 30 minutes, $1. So we're going to put these points on our graph, okay? So 10 minutes, I'm going to go to the 10 for the minutes, is going to cost me 40 cents. So it's going to be probably right around here, okay? 0.4 is right below 0.5. 20 minutes is going to cost 70 cents. So I would say that is probably right around here. And then 30 minutes is going to cost exactly that $1 mark. Okay, so we've plotted those 3 points like they told us to. And it says they appear to make a line, which they do, right? You can see clearly that these are, if we connect them, making a line. What information about the access plan suggests that this model is linear? So how do we know that this is linear? Well, we can tell because obviously our graph forms a line. But also, we can tell based on the relationship in our table. So additionally, we can look at this and we can find the constant rate. So let's do that real quick. So remember our constant rate, or m, is y2 minus y1 over x2 minus x1. And I'm just going to choose any two x and y pairs here. So the first one I'm going to choose is this for my y2. So this is $1 minus 0.70, my y1, over x2 minus x1, 30 minus 20. Okay, what I get on top is 0.3 over 10. And if I do that math out, 0.3 divided by 10 is going to be 0.03. Zoom out a little bit. All right, so that's my rate for these 2 rows right here. Now I'm going to do these 2 rows up here. So the same thing, y2 minus y1. This time my y2 is 0.7 minus y1, 0.4 over x2, which is 20 minus 10. Well, 70 minus 40 is the same as 0.70 minus 0.40, and that leaves me with 0.3 or 0.30, and 20 take away 10 is 10. And again, when I do this in my calculator, I'm going to get the same thing. So what I've noticed here is that for both pairs of numbers, I get the same m, or the same constant rate. So our graph does form a line, but also our table has a constant rate. And our constant rate is 0.03. Okay, so that's how we know that this is linear. Obviously, you can always look at a graph and think, oh yeah, that looks like a line. But to prove it, you have to look at your constant rate, which we did here, and we found it was 0.03 both times. Okay, we're going to continue on the next slide with this. All right, we are continuing to interpret this situation here. It says number 2, the rate of change describes how the cost changes with respect to time. So we already found that the rate of change is 0.03. So what that means is that this is how much the cost changes over time. Okay? A says when the number of minutes increases by 10, So when we go from 10 minutes to 20 minutes or 20 minutes to 30 minutes, how much does the charge increase? So if you think back, when we were at 10 minutes, we paid 40 cents. When we were at 20 minutes, we paid 70 cents. When we were at 30 minutes, we paid $1. So how much does that charge increase every 10 minutes? So every 10 minutes, we went up 30 cents, right? So when we went 10 minutes to 20 minutes, we went from 40 cents to 70 cents. 20 minutes to 30 minutes, we went from 70 cents to $1, okay? B says, another way to say this would be that the usage charge per 10 minutes of use. Use that information to determine the increase in cost based on only 1 minute of additional usage. So if every 10 minutes, it's going to cost us 30 cents, it wants us to figure out, well, what's in 1 minute? And we already did this on the other page. It's just showing you this relationship. So basically, these are going to be equivalent fractions, and we already know that the constant rate for 1 minute is what we found on that last page, 0.03. It's just showing you a different way to kind of figure this out. So in 10 minutes, you increase 30 cents. That means in 1 minute, you increase 3 cents. All we did was move our decimal point one place. So here, we moved it one place back to get to 1, moved it one place back to get to 0.03. So in 1 minute, we increase 3 cents. All right, and that is our constant rate here. So for every minute, she gets charged 3 cents. That's what we have determined is our constant rate. Let's continue on the next slide. All right, continuing here, what we're going to do is we're going to figure out, well, if in 10 minutes it costs us 40 cents, in 20 minutes it costs us, or her 70 cents, in 30 minutes it cost her $1. Oops. How much is it going to cost for 40 minutes, for 50 minutes, and for 60 minutes of use? Okay, so go ahead and try your hand at this. Try to figure out how much is it going to cost her based on our constant rate for each of these times, 40 minutes, 50 minutes, and 60 minutes. What do you get? Well, you should remember that from the last few slides, every time we increase by 10 minutes, we increase by 30 cents. So for 40 minutes, she's going to pay $1.30. For 50 minutes, she's going to pay $1.60. And for 60 minutes, for 1 hour, she's going to pay $1.90. Okay? We're now going to graph these, or what told us to graph them on that coordinate plane back on a few slides ago, but we're not going to graph them. We're just going to keep these in mind, okay? And continue with number 4. All right, number 4 says, what would be the hypothetical cost for 0 minutes of use? That means if we went all the way back, how much is it going to pay for not using this access plan at all? Okay, so let's think about it. If we were at, let's work backwards maybe, 10 minutes, and this costs us 40 cents. Let's go back 10 minutes. How much is that going to cost us? Well, we increased by 30 cents each time. So if we took 30 cents away from 40 cents, we're going to get that this is going to cost us 10 cents. So for 0 minutes of use, she still pays 10 cents. Okay? It says, put that on the graph and draw your line through them. Okay? And the slope is our constant rate of change. Well, we went ahead and we found that our constant rate of change was 0.03. Okay, we did that already. And now we're just going to be able to write our equation down here. So remember, we write our equations in the form of y equals mx plus b, where m is our constant rate and b is our y-intercept, or this is our initial cost. Okay? Where are we starting? All right, and then this is what we add on each time, or every minute. So this is our constant rate. We found that our constant rate was 0.03, so we can write this as y equals 0.03x plus, what are we starting with? How much does it cost to just log into this thing and not even use it? Just the access fee. Well, we found at the very top of this that for 0 minutes of use, without even using this, she's still going to pay 10 cents. So she's going to have to pay 10 cents no matter what when she logs in. Okay? So again, this is our equation, and here's what it means. It means that the total cost is going to be 0.03 or 3 cents per minute plus 10 cents to log in. All right, so this is our final equation that we found from this linear function. And we're just going to continue now with example number 2 and do some more exercises just to practice interpreting these things. All right, example 2, it says another rate plan. So a second wireless company has a similar method for computing its cost. Unlike the first company that Lenore was considering, the second company basically tells you that the access fee is 15 cents and they charge 4 cents a minute. Okay? So we have here that the total session cost is 15 cents plus 4 cents for every minute that you spend using it. It says let x represent the number of minutes used and y represent the total cost in session dollars. Construct a linear function that models the total session cost based on the number of minutes used. So y is going to represent the total session cost. So we have y equals, and then we're going to add this in, 0.15 plus 0.04, times the number of minutes. Well, it says let x represent the number of minutes. So this becomes an x. So this is y, that's our x. Okay. So this is our equation. The only thing I'm going to change up here is instead of saying y equals 0.15 plus 0.04x, I'm going to change it to y equals this first, and then plus this. Y equals mx plus b. Okay? So again, what this means here is that this is the constant rate, this is the m. So this is the constant rate, this is what she pays every minute. She pays 4 cents each minute. And this is our b, this is our y-intercept, this is where we're starting. Just to log in, she pays 15 cents. Okay, to not even use this thing. All right, so make sure you have this down. We've kind of interpreted this session, or this wireless access company, and then we're going to do a little bit more with it on the next couple of slides. All right, based on that relationship that we found on the last slide, and I put it at the top, you should too, we're going to fill out this table. So we're going to figure out, okay, well, how much does it cost when she's there for 0 minutes, for 10 minutes, 20, 30, 40, 50, 60, etc. And we're going to fill this in. So for 0 minutes, that means that we are changing this x to a 0. Well, y equals 0.04 times 0 plus 0.15. 0.04 times 0 is 0. Plus 15 cents, 0 plus 15 cents, she's just going to pay 15 cents. So when she doesn't spend any time actually using this plan, she just logs in, she's going to pay 15 cents. All right? Now let's see how much she's going to pay when it's 10 cents. So I'm changing that to a 10. So y equals 0.04 this time times 10 plus the 15 cents. Well, anything times 10, all we got to do is move the decimal one place to the right. So this becomes 40 cents plus that 15 cents to begin with. 40 cents plus 15 cents is she's going to pay 55 cents for 10 minutes. Okay? Moving to the next one, 20 minutes. We're going to change our x value to a 20 because now we're spending 20 minutes using this service. Well, 0.04 times 20 is going to be 80 cents. And then we're doing that 80 cents that it costs to use it for 20 minutes plus 15 cents that it costs just to log on. This is going to give us a total of 95 cents. Okay? So I've done about half of this table for you. I want you to go ahead and give it a try, and please try out 30, 40, 50, and 60 minutes and fill in these remaining rows. Okay, and we'll go over it in a couple of minutes. Please go ahead and get started. All right, going over these, when we do 0.04 times 30, or for finding the fee that it's going to cost for 30 minutes of use, we get 1.2, and then we're adding this 0.15. We should get $1.35 for 30 minutes. Okay. For the next one, when you're figuring out 40 minutes of usage, we're timesing that by 0.04, and then we're adding 15 cents to that, and we should get $1.75. All right. When we're doing 50 minutes, we're doing 50 times 0.04, and then we're adding 15 cents to that, and you should have got $2.15. Now, one thing I want to do with you before we go to the next one here is I just want to point out that you can now find a pattern in this table, right? We are increasing each time by the same amount. We go from 15 cents to 55 cents, 55 cents to 95 cents, 95 to $1.35. So each time we are increasing by 40 cents, right? So 40 cents more to 15 plus 40, this is going to give us $2.55. And we can check it with our equation if we need to. But what you should see is this relationship kind of playing out and kind of starting to understand what numbers mean here. So basically, every time you increase by 10 minutes on this side, you increase by 40 cents on this side, right? So each additional 10 minutes is going to cost you an additional 40 cents. And one thing I want to point out is that at 0 minutes, before we even started using this service, at the very beginning, we are starting by paying 15 cents just to log in. Okay? So those are the two numbers, the two relationships that are going to help us out here. This is our B value, our y-intercept, and this is our M value. Okay? It's our constant rate. We're going to use this to kind of interpret a little bit more on the next slide. Make sure you have this down before we move on. All right, for number 9, it does tell us to plot these as a graph with our graph from exercise 1. I'm not going to do that, but I am going to interpret it. Basically, it says, how do the two plans differ? So if you think back to that first exercise for plan number 1, we were paying a certain amount. So this is what we're paying for plan number 1. Our equation was y equals 0.03 x mx plus b, and our b value that we were starting with was 0.10 or 10 cents. So our first plan was 3 cents a minute plus 10 cents to log in. Our second plan, the one we just did, our constant rate, we were going up 40 cents every 10 minutes. That means every 1 minute, we're going up 4 cents. and it cost us 15 cents to log in. So 4 cents for every minute we use plus 15 cents to log in. So here's the difference between these. For plan 1, it costs 10 cents to log in. For plan 2, it costs 15 cents to log in. All right, so that's the difference here. And then what else is different is our constant rate. For plan 1, it costs 3 cents each minute we use it. For plan 2, it costs 4 cents. Okay, so that's the difference here. All right, again, this lesson is just about interpreting real life situations, putting them into mathematical representations, and then being able to understand what these things mean. So I'm trying to show you exactly what everything means here and where you find that information, okay? Make sure you have this down. Let me know if you have any questions before we move on. All right, just to summarize our lesson today, a linear function can be used to model linear relationships between two types of quantities. The graph of a linear function, keyword linear, is a straight line. Okay? A linear function can be constructed using rate of change, that's our m, and initial value, that's our b, that's where we start. It can be interpreted as an equation of a line, okay, in which that rate of change, that m value, is the slope, and it describes how the quantity changes with respect to another quantity. So in our example today, it was how much money you pay per minute. And that initial value, that's our y-intercept, our b value. Okay, so that is just to summarize our lesson before we move into our exit ticket today. We're now going to go over our exit ticket. All right, you will be doing this in Galileo, and it'll look a little bit different in terms of how the questions are shown to you. But here's our situation. It says a rental car company offers a rental package for a mid-sized car. The cost comprises of a $30 fixed administration fee, so that is your initial fee, for the cleaning and maintenance, plus $35 per day. And what that means is that you're going to pay $35 times every day that you use it. So this is your rate, daily rate, okay? For that situation, number 1 says using x for the number of days and y for the cost in dollars, it wants you to create a function to model this relationship. So essentially it's saying write an equation y equals mx plus b format. All right, that's going to be your first question. Remember that m is your rate, b, this is your initial value or your initial starting place. How much do you pay just to begin with, okay? And this is how much you pay per something. So you're going to write that in, okay? That's your first part. Number 2 says the same company is advertising a deal on their compact car rentals. The linear function y equals 30x plus 15. So I'll write that here because you can't really see it. 30x plus 15 is used to model that relationship. What is the administrative fee? So looking at this relationship, it's asking you, what is this administrative fee? Okay, just looking at your equation, you should be able to tell how much does it cost just for that fee. Okay, there's a number within this equation that represents the fee. You need to figure out what that means. Okay, and then the second question is pretty much the same thing, except this time it's saying what's the cost per day. So again, within this equation, there's 2 numbers, right? One's going to represent that administrative fee, and one's going to represent the cost per day. So it's either going to be 30 or 15. Your answers for A and B here. You need to figure out which one represents what. Okay, and that is your exit ticket for today. After finishing your exit ticket, please complete your lesson reflection, which is in Google Classroom.